All right, let's perform a linear regression t-test with computer output. All right, so let's remember the components to this because everything is given to you. You're not putting data into your calculator and then running the test in the calculator. Remember that this word here is going to be your x variable, your explanatory variable. So this line is about slope. There is your slope, and there is the standard deviation of your slope. All right, so then I have, y'all can come on in, even though, and then I have this is the line about the y-intercept. Okay, and that's about all we really care about as far as the line goes. Okay, as far as the y-intercept goes, sorry. And then recall that this here, S, right here, is the standard deviation of the residuals. Okay, so here we go. Now let's, again, I have defined some variables for you that we need to know. So we know R and R squared. We're familiar with that. And I already told you in the previous video how the little b is that slope of the sample. Okay, and beta is not on here because that's what we are hypothesizing about. So beta is that slope of the population. But let's take a look at these things here. We need to start getting used to this notation. S and S with the little e, because that's the errors. How much the residual, the data actual is off from predicted. That's an error. So that's S with a little e. And so those two are synonymous. So you can represent the standard deviation of the residuals by S or S with a little e. Now, look at this. S with a little b, because remember, b is the slope. S with a little b is the variable we will use for standard deviation of the slope. Okay, so it's important that you tuck away this notation, especially S with a little e and S with a little b. Okay, so here we go. Remember, we've already actually talked about this when we did our linear regression review, the standard deviation of the slope, the average amount, that the actual, oh, that's not right, that's standard deviation. Let's see, if you sample many times, how much you'd expect the slope to vary on average over time. And then we have that standard deviation of the residual. So you're going to practice these. I'll continue to practice these. Okay, so here we go. Here's our problem with the computer printout. Now, so we have United Kingdom's largest distance learning university wants to investigate the relationship between two key aspects of their assessments. Review resources and how much time they spent reviewing. So I can see, look down here in my computer printout. Review time is that X variable, that explanatory variable. Okay? And then the examination score itself. So that's the response. So, and so on and so forth. Now, I had forgotten to put this in here. The following is the regression analysis for a sample of 18. That's important. You need to know that for degrees of freedom. All right, so we know then our degrees of freedom are 16. So explanatory, time spent reviewing, response, exam. Okay, the equation of the line. It's coming from these two numbers here. This 0.55528 slope, and then there's the one above it is the y-intercept. So there's that. There's your coefficient, correlation coefficient, coefficient of termination. Okay, so I'm afraid I'm kind of going to run out of time here. So I'm going to zoom past number 3 and number 4. We've already kind of done those before, and you could look these up in the notes. Also, the same thing, we just recently practiced. Look, state and interpret in context the standard deviation of the slope. Look what notation I used, S with a little b. State and interpret in context the standard deviation of the residuals, S with a little e, which is this right here, that S, okay, that plain S. All right, now On the top of the next page, does the positive slope provide convincing evidence that longer review time will result in a higher exam score? So they're asking if there's basically a positive relationship between review time and the exam score. So we need to be able to get statistical evidence. We're going to run a linear regression t-test. So here we go. Our beta is the slope of the relationship between review time and exam score. And we were hypothesizing that, we're investigating, so our HA, we're investigating if it is positive. Assumptions we will do later, so we get to skip those. Linear regression t-test. Okay, here we go. Now, if you notice over here, this is missing. The t-score and the p-value are missing. Those, in a real computer printout, those are there. But I made those missing on purpose because it's a common thing for College Board to leave those blank so they can see if you can get those on your own. Okay? And so I left those blank so we can practice that. So here we go. Look at how we get our t-score. We are going to do our little b sample minus the hypothesized beta over the standard deviation of the slope. So t equals, sample slope minus beta over the standard deviation of the slope. So I filled in those numbers, got a huge t-score. To get the p-value, I'm TCDFing it up above to 99 with 16 degrees of freedom. That's why it mattered. I was supposed to have told you the size of the sample. I had to go back and fix that. So look, our p-value is basically 0. Now, notice, see, our hypothesized value was 0. That's the most common beta. I've seen it only once on an AP question be something else. I've seen it be 2 before, but otherwise, it's mostly always 0. And there's our p-value, less than alpha. So what are we going to do then? Reject HO. So we have evidence that there is in fact, a positive, I could say that in here. We have evidence that of a positive linear relationship between review time and the exam score for all students. Okay, I think that's the end of that. Yes, it is. So, you've learned the basics of a hypothesis test. You know how to do it with data you put in your calculator. And you know how to do it with a computer printout where you have to compute the t-score on your own and p-value. Here's a review. Remember to get the t-score, sample slope minus beta over the standard deviation of the slope. So see, there was the standard deviation of the slope. Here was the slope, minus 0. Okay, so there you go. And don't forget, you need to keep practicing all of these other interpretations. All right, so good luck to you on your assignment.